The hand sanitizer they have in here is stinky. Smells like, well, booze. It smells like booze. But it also kind of smells like dog. Like dog that needs a bath. Okay. Anyways, today we are going to look at section 2.7 in our textbook, and we are going to look at derivatives and rate of change. We are covering this in 5 subtopics. We're going to look at tangents first. Then we're going to look at the alternative definition of a tangent, velocities. Then we're going to look at derivatives, and then we're going to look at interpretation of the derivative. This is quite a hefty section, so make sure you got your pencils and paper ready. Take some notes. First thing, let's look at tangents. So we've talked about this before, but basically you have a function. You have 2 points on that function, P and Q. And the idea is you want them to get closer and closer and closer together. So in section 2.1, we looked at the slope of the tangent line between the points P and Q. And P can be defined as A and f of A. And then point Q is some arbitrary point X. And if we take the slopes and we look at the limit of the slopes of the secant lines as we move point Q and P closer together. So the slope of the tangent line to the curve y equals f of x can be found at point P by finding the following limit. As long as the limit exists, you can use this formula to find the slope of the tangent. Keep in mind, if you ever forget this formula, you can just draw yourself a picture. Draw the points Q and P, and then use the slope formula. That's how this formula is found. Then just take the limit as x approaches A. Now, I just want to point out, this is not technical, official, mathematic writing. It is just a kind of a way that I write when I say I'm finding the slope of the tangent at x equals A. And you're going to see me write that when I work in my examples. Let's look at an example. So I've got the equation of f of x as x squared plus 2x. I'm looking specifically at the point 1, 3, and they want us to find the equation of the tangent line to the curve at that point. Okie dokie. All right, if we want to find the equation of the tangent line, keep in mind. So first thing we need to do is we need to find the slope of the tangent. All right, we are going to use this formula. Going to look the limit as x approaches 1 of f of x minus f of 1 all over x minus 1. Remember, we do arbitrary minus specific. Okay, so f of x, the function is given as x squared plus 2x. Now, f of 1, that value is given too. That's this 3, okay? That's my output value. So I'm going to subtract that value. Remember, I take the difference in the slope formula. Next, x minus 1 is already put forth. If I plug 1 in first, which is what I always want to do, plug 1 in first, I end up with 0 on the top and 0 on the bottom. And that's not okay. Can't have a 0 on the bottom. So I'm going to try to cancel some things. Before I can cancel, I need to break stuff up. So I'm going to factor the top function. And that factors into x plus 3 and x minus 1. And then I'm going to factor the denominator. I'm sorry, I don't need to factor. It's already factored. But I can see that these two will cancel, which is excellent, which means that I can find the limit now. The limit as x approaches 1 of x plus 3 is going to be 4. All right, perfect. That means I found my slope of the tangent. My slope of the tangent is 4. Next, I'm going to find my equation. Okay? Next, I'm going to find my equation. I am going to use the point slope formula. Sorry for all the squeaking. And I'm going to plug in my given point, and I'm going to plug in the slope I just found. So this thing right here, this is going to get my 4. My x value is that value of 1 for the point. My y value is the value of 3 for the point. So I'm going to have y minus 3 equals 4 times x minus 1. In order to solve this for y, I just need to multiply out the 4 and add the 3. Sorry for the squeaking. I don't know if it's driving you crazy. I hope it's not as loud on the recording as it is in person. I'm going to add 3. So I got -1. All right, this right here, this is the equation of the tangent line. If you don't believe me, remember, you can always check your work. You can take this equation, plug that into your calculator, and then plug this equation into your calculator. See, do they intersect in tangent-like behavior? Do they intersect in tangent-like behavior? And specifically, do they intersect at that point 1, 3? It's a good way to check. Okay, let's look at the alternative definition for a tangent. The alternate definition for the slope of the tangent can be thought of in a slightly different way. Again, we have points P and Q, and we're imagining that they're getting closer and closer together. But instead of thinking it with X's and A's, we think about it with A's and H's. And H is the distance between points P and Q, specifically the X values of P and Q, and we imagine that they are getting closer and closer and closer. And so effectively, we're again taking the limit, and we're looking for where the distance between these 2 points is approaching 0. This gives us our second definition for a limit. Again, this can be found by just taking the slope formula of this point Q and this point P and finding the slope value, simplifying it, and then taking the limit as h approaches 0. And we can find the slope of the tangent as long as this limit exists. Now we have a couple of examples. I want to show how we can do this using both definitions. I'd like you to know for this class, you do not have to have both definitions memorized as far as which one's number 1 and which one's number 2. You do have to have the formulas memorized though. So if I say find the slope of the tangent using definition 1, you don't have to worry about me actually doing that. I'm not going to. I'm just going to ask you to find the slope of the tangent, and you just need to know that there are 2 ways to do it. All right, let's try it with the first way. Okay, I've got the curve x minus x cubed, and I want to find the slope of the tangent line at the point 1, 0. Using definition number 1, I've got the limit as x approaches 1, because that's my a value. The a value is the x coordinate, of f of x. F of x is the equation. And then I'm going to subtract from f of x. I'm going to subtract the y coordinate, which in this case is 0. Nice. Makes it a little bit easier on us. And then I'm going to fill that in for the denominator of x minus 1. If I plug 1 in, I notice I get 0 over 0. So I go on with my math. I'm going to factor the numerator. I'm going to ignore the 0 right here. I am going to factor an x out of the numerator, and I end up with 1 minus x squared. Okie dokie. That is a difference of squares. So I'm going to take x and then here factor the difference of squares. And I end up with this. Now, be mindful. I've got 1 minus x and x minus 1. Those do cancel, but I don't know if you remember this from a previous lecture. When they're subtracting each other and they're in opposite order, they will cancel each other, but they leave behind a what? Yeah, a -1. This is 1. We can ignore it. Okay. Now I'm going to plug in 1. So I'm going to have 1 times 1 plus 1, which is going to give me 2. All right. So using this definition, the slope of the tangent, I found that to be 2. Specifically at the point x equals 1. All right. Let's try it using the other formula. This one can sometimes be a little bit more arduous because we have more variables at play. You ready? Okay. Okay. So, actually, I probably should give myself some room. This one's going to be a little bit longer because we're cubing this value. I don't want to erase it. It takes so long. Let's see what happens. We'll do it in blue. We'll see if I can write small-ish. Okie dokie. All right, so we're going to do the limit as h approaches 0 of f of a plus h. So here's a plus h, because f is x minus x cubed. So I'm going to have a plus h minus a plus h cubed minus f of a. And in this case, and actually, sorry, my a is 1. So I don't want to use a. I want to use 1 here. And then f of a is 0. Yay, makes it a little bit easier. And then we're going to put this all over h. Now, if I evaluate this limit with h equals 0, I am going to get 0 over 0. So that means I have to do some simplifying. So I'm going to do that. Okay, 1 plus h, that just stays the same. Minus. Now I'm going to cube 1 plus h. This will give me 1 plus 3h plus 3h squared plus h cubed. And that's all over h. Okay, now for this one, I need to, and I don't know if you remember, this is that whole Pascal's triangle thing. You do the whole 1, 1, 2, 1, 1, 3, 3, 1. And then cube it using the 1, 3, 3, 1. 1 starts at 1 to the 3rd and goes down. H starts at h to the 0 and goes up. Okay, now we're going to simplify this stuff. So if I distribute this negative sign, I'm going to end up with a couple of things canceling. All right? So first, my 1s are going to cancel. Next, I've got this h minus 3h. So that's not going to cancel, but it is going to combine. So I'm going to end up with h minus 3h, which is going to give me a negative 2h. I'm going to distribute out this negative 3h squared, and distribute out this negative h cubed, and then that's all going to be over h. Now, boy, doesn't that look messy? However, this is good. Everybody has an h in it, okay? You want that because you're trying to get this h to cancel because h equaling 0 is a no-no when the h is in the denominator. So since everybody has an h, that means that you can factor an h out of everything. So let's do that. So this h is going to factor out. This h here is going to be h squared is going to turn into h, and h cubed is going to turn into h squared. All right, so I'm going to have negative 2, and then I'm going to have minus 3h and minus h squared. Okay, now I can plug in my h equals 0, as I've got something that canceled. If I plug in h equals 0, this term goes away here, the minus h squared goes away here, and I end up with negative 2 minus 0, which is going to give me negative 2. And then I think to myself, because it's not supposed to be negative 2, it's supposed to be positive 2. So the slope of the tangent is wrong about something. It is supposed to be negative 1 minus 3x squared. Yeah, it is supposed to be negative 2. Which means my mistake's over here. So f of x, x minus 1. Oh, shnikes! I see it! See this negative 1? I forgot to put it in there. That's math for you. Okay. Now, think about this. When you're doing your test, you should be able to do it both ways and get the same answer. So, like in this situation that I have right here, I got a 2 and a negative 2, and I think to myself, oh no, that's not the same. But it means one of them is a mistake. Okay. Good thing we found it. Thanks for helping me out. I really appreciate that. So now that we have found the slope, we've found the slope of the tangent, and we know that it's negative 2. Now what we can do is find the equation. And I'm not going to do it with this very loud marker. Do I have another green one? Nope. All right, so we're going to use, oh, this is just as squeaky. Oh, a little bit better if I turn it. I use the point slope formula and the point that I've been given. So my y coordinate, that is 0. I'm going to plug 0 into there. My slope of the tangent is negative 2, so I'm going to plug that into there. And my a value, which is my x value of my coordinate, that's going to be 1. So I'm going to end up with y minus 0 equals negative 2 times x minus 1. This one's a quick solve. I just need to distribute the negative 2, and I'm done. All right, good. This right here, this is the equation of the tangent line. And we use both definitions to find the slope of the tangent. Pretty cool, huh? Now we're on to the third section of 2.7. We're going to talk about velocities. So keep in mind, if you have an object that's moving along a straight line according to an equation of motion s, which is a function of t time, in the time interval from t equals a to t equals a plus h, then the change in position is going to be denoted by f of a plus h minus f of a. You're just taking the difference of the outputs. If you want to find the average velocity, you're going to take your displacement and put it over time, which is going to be your change in position over your change in time, which is going to be the slope formula of those 2 points, f of a plus h minus f of a all over h. Average velocity, that's the secant. The instantaneous velocity can be found by taking the limit as h approaches 0 of your average velocity, which gives you this function right here, this limit. Keep in mind it's instantaneous velocity, or just called velocity, at some point A is going to be the limit as h approaches 0 of f of a plus h minus f of a divided by h. All right, we're back on Mars. Same function, we're throwing rocks on Mars. Initial velocity is 10 meters per second. The height in meters t seconds is given by this function, y equals f of t, which is equal to 10t minus 1.86 t squared. Let's find the velocity of that rock when t is equal to 2. All right, so what we're looking for is we want to find the velocity at t equals 2. So that's going to be the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Keep in mind why that is. Remember the general formula. Can I squeeze it in up here? The general formula is the limit as h approaches 0 of f of a plus h minus f of a all over h. And in this case, we're looking for when the velocity is, we're looking for that at 2, with t equals 2 or a equals 2 in this particular case for this formula. So let's evaluate this. So f of 2 plus h, what we're going to do is we're going to take 10t minus 1.86 t squared, and we're going to plug in 2 plus h. And then we're going to subtract when we plug in 2. And I'm just going to write in f of 2 for the moment. Don't forget your limit statement. I almost did. I'm going to squeeze it in here with a little arrow. You can't see that. Ah! Fumble! There we go. Squeeze it in there all over h. All right, let's do some evaluating. We're going to distribute out the 10 over here. I'm going to distribute that out. So I'm going to get 20 plus 10h. I'm going to distribute out the 1.86 in a second. I'm going to square this first. When I square this function, I end up with this. And then f of 2, if I plug 2 into this function, sorry, I get 12.56, and that's still over h. All right, next. If I see a mistake already, this is supposed to be 10h. All right, next I'm going to distribute out that 1.86 on my velocity. All right, 1.86 times 4. And I'm multiplying by 4 again. H, and then minus 1.86 h squared, and then minus 12.56. Time for a different orange marker. I've already gone through 2 and I've only started 1 problem. Okay, now I'm going to combine like terms. I've got 20, and I'm going to subtract from that 7.44, and then I'm going to subtract from that 12.56. Yes! And those cancel. Cancel, cancel, cancel. Now I'm going to combine my h's. So I'm going to get 10h minus 7.44h, and I'm going to get 2.56h, and then I've got that 1.6h squared all over h. All right, this is good. This means that this velocity calculations are going well because everything canceled that didn't have an h. So now I'm going to factor an h out of everybody. Keep in mind what I'm doing. I'm going to show it as a separate step for a second. If I factor the h out of every term in the top, I end up with this h, and then those guys cancel. And then I can plug in h equals 0. And I end up with 2.56 velocity of meters per second. So 2 seconds after I'm throwing rocks on Mars, my rock is going 2.56 meters per second at that instant of t equals 2. On to the next section. We're going to look at derivatives. The derivative of a function f at a number a, denoted by f prime of a, is defined by this very familiar looking function, don't you think? As long as this limit exists, this is how we can find f prime of a. Prime tells us that we're looking for the derivative. Notice that if we write x equals a plus h, and then we subtract them, we end up with h. That's why if h approaches 0, then x is approaching a. And then this leads to the next definition. Second definition for the derivative is when we're looking at a specific point of A. This is the one that you want to use if you're looking for, basically, I think the last one would have been easier to do this way. If you're looking for a velocity or a derivative at a particular point A. As long as you can find this limit, you can use this second definition. Let's practice it. I'm going to find the derivative for this function using definition 1. So I'm going to use sorry for the squeaking, this limit definition here. So for f of a plus h, keep in mind, and actually I'm going to write it up here. If I'm trying to find f of a, just regular f of a, all I'm going to do is plug a into this function for x. So I end up with a cubed minus 4 times a. If I'm trying to find f of a plus h, that means I'm trying to find a plus h cubed minus 4 times a plus h. Excuse me, and that's a little close. I'm just going to... You're welcome for the sound effects. I'm going to have to find that for f of a plus h. So f of a plus h is what goes first, and then I'm going to subtract f of a. So f of a plus h is going to be that a plus h cubed minus 4 times a plus h. And then I'm going to subtract f of a, which is that a cubed minus 4a. And don't forget, I keep forgetting, the limit statement. Third marker down, second problem. That doesn't bode well for today's recording session. Alrighty, now I'm gonna do a bunch of math. So I'm gonna cube a plus h. Remember, we use that Pascal's triangle. That's this thing where you go 1, 1, 2, 1, 1, 3, 3, 1. And we're gonna use that third row. We go a cubed, a squared, a to the 1, and a to the 0. And then we do h to the 0, h to the 1, h to the 2, h3. If you don't know what I'm talking about, watch one of the previous videos. So I'm going to cube a plus h. So that's this piece right here. Then I'm going to distribute out the 4, the negative 4. And then I'm going to distribute out the negative for subtracting that f of a. Always double check your arithmetic because that part that we just did is an easy one to make a mistake in. All right, you ready? Hopefully, everything, when we simplify it, everything without an h would cancel. So let's take a peek. All right, I've got a cubed minus a cubed. Bam, cancel. This has an h, so I just look to see if I can combine it with anybody else. I can't. This has an h. Look to see if I can combine it. I can't. Now, I've got minus 4a and minus 4a. Oh, here we go. Minus 4a and plus 4a. I'm distracted by this 4a here. What did I write it twice? H cubed minus I. Here's my mistake. Sorry, it was the squeaky marker. This is supposed to be for h. And then that is it for canceling. So I'm good. I'm good for canceling. So let's go ahead and look at what we have. Limit as h approaches 0. I've got 3 a squared h plus 3 ah squared plus h cubed minus 4h. Oh my gosh, all over h. Marker number 4 has bit the dust on the second problem. I'm probably not going to be using orange much longer. Okay, notice everybody has an h. That's good. So anything without an h canceled. Everybody with an h is left behind. That means that we can factor an h out. So h's are going to factor out. I am going to be left with, let me show this in a different color. This cancels, this becomes 1, this becomes 2, this cancels, and this cancels. I can show it as factoring out the h on the top and then canceling with the h, or I can do it like that. It's up to you. Creative freedom. So then I have the limit as h approaches 0 of 3a squared plus 3ah plus h squared minus 4. And now that I've canceled that pesky h in the denominator, I can go ahead and plug in my x equals, or my h equals 0. And when I do, notice what happens. Nothing here, but this one approaches 0 and this one approaches 0. And what I end up with is 3a squared minus 4. And that's my answer. F prime of a is 3a squared minus 4. Let's move on to the next section of 2.7, which is interpretation of the derivative. So in other words, we want to take the derivative and interpret it. So the derivative is the slope of the tangent line. Okay, remember that slope of the tangent line? That's what we're trying to find with the derivative. The slope of the tangent line can be found in the following manner, as long as you know the point A and f of A, and that will give you f prime of A. Let's do an example of that. let's find the equation of the tangent line to this curve at these 2 points. I want to find the equation of the tangent line at 2, 0, and the equation of the tangent line at 0, 0. So remember, previously, we found f prime of a already. So we found the formula for the derivative of this particular function, and it was 3a squared minus 4. So if I'm trying to find the equation of the tangent line, what I'm going to do first is I need to find the slope of the tangent line, and then I'm going to find the equation of the tangent line. So the slope, what I need to do is I need to plug in, since I'm finding it at x equals 2, I'm going to plug in 2 to my function here. So I'm going to get 3 times 4, which is 12, minus 4, which is 8. So f prime of 2 is going to give me 8. Now I'm going to find the equation of the tangent line. Remember how to find the equation of a line. I'm going to plug in my points and my slope. So my slope goes right here. My points go right here. My point is 2, 0. So my y coordinate is 0, so I'm going to have y equals 0. My slope is 8, so my slope here is going to get 8. And then my x coordinate is 2, so I'm going to get x minus 2. And then to find this equation, y minus 0 is just going to give me y. I just need to distribute this out, and I end up with 8x minus 16. This is going to be the equation of my tangent line at 2, 0. Remember, you can graph this function and then graph your tangent equation, see if they look like they're tangents to each other, and verify that they intersect at this point 2, 0. Let's try the next one. So the next one, now I'm going to do the slope of the tangent. Again, I'm still going to use my f prime of a, but now I'm using x is equal to 0. So I'm going to find f prime of 0. When I plug 0 into this function, I'm going to end up with 3 times 0 squared minus 4, which means the slope of this tangent at x equals 0 is equal to negative 4. Now I'm going to find the equation of the tangent line. So my formula, I'm going to write that down for finding the equation of a line. My y coordinate happens to be 0, so I'm going to have y minus 0. My slope is negative 4, so I'm going to plug in negative 4. And my x coordinate is 0 as well, so I'm going to plug in x minus 0. If I distribute the negative 4, that's the only thing I need to do, and drop those zeros, I find that the equation of the tangent to this curve at the point 0, 0 is y equals negative 4x. For this second part, we're going to look at the derivative as an instantaneous rate of change. So suppose you have some function f of x, which is a quantity y, defined with respect to another quantity x. If you want to find the average rate of change over an interval of x, say as x goes from x sub 1 to x sub 2, then we can find the average rate of change using, again, the slope formula. Find your change in y over your change in x. In other words, subtract your output values and divide that by the difference of your input values. By taking the limit of this average rate of change, we get this, which gives us our instantaneous rate of change. And instantaneous rate of change can be found in a couple of different ways. We can look at this as x sub 1 approaches x sub 2 of that slope formula, or consider when delta x approaches 0 of this delta y over delta x. Remember, delta means change. Note, when we're talking about instantaneous rates of change, if s is your position function of an object, then f prime of a is the rate of change of the displacement s of your object with respect to the time t. Thus, f prime of a is your instantaneous rate of change of y with respect to x when a is equal to 0. Furthermore, the speed is going to be the absolute value of that velocity function, or the absolute value of the derivative of f, or f prime of a. A couple notes to keep in mind. Velocity indicates direction with sign. If I go somewhere at my starting point, if I start to move away in the positive direction or move away from my origin, I am going to have a positive sign. When I start moving back towards my origin, then I'm going to have a negative sign. So positive velocity means the object is moving away from your original position. Negative velocity means that your object is moving towards the original position. So if I throw something from the ground, when it goes up, 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 it's going to have positive velocity. But once that thing reaches its apex and starts to come down, it's going to have a negative velocity. But speed doesn't have a sign, which is why we use the absolute values.